Hello, my friend. Good morning, good afternoon, good evening, whenever you are. I am thrilled to have you join me for this lecture in total quality management. As you know, actually, my name is Farnaz, and in this 13th session, we will explore the different types of control charts, focusing on their applications, interpretations, and the insights they provide. Control charts are powerful tools in ensuring consistent quality in production and identifying areas where processes may need improvement. In previous lecture, um, we discussed the statistical distribution such as PDF, CDF, and PMF. We also introduced the Six Sigma concept as a method for reducing process variability. Now we will shift gears to discuss the practical implications of monitoring tools such as control charts. Specifically, we will dive into X-bar charts, R charts, and attribute charts like P, C, and U chart. And I want to more explain about this information that happened about P, C, and U chart in this session. These tools are foundational for maintaining processes control and achieving quality improvement. So let's start. Control charts are essential for monitoring processes over time. They help determine whether a process is stable or if there are deviations due to spatial or assignable causes. X-bar and R charts used to monitor variable data such as weight, dimensions, or strength. P, C, and U charts used for attribute data such as the proportion of defective item or counts of error. Every control chart has three lines. We should remember these key lines that every control chart should be compliant. Central line, I mean the CL, represents the process average. Upper control limit is UCL, indicates the highest acceptable value for the process. Lower control limit is LCL, indicates the lowest acceptable value. These limits are calculated based on the standard deviation, I mean sigma, and the desired confidence level. As I showed you for the previous session, that chart about the that show you the standard deviation in the range of -6 and +6. So -6 standard deviation and +6 standard deviation. Um, in this chart, um, actually represented that the for 99% of confidence is between +3 and the -3 standard deviation, and for 95% confidence is between +2 and -2 standard deviation. X bar and R charts for variables. If we want to have a brief explanation about, we can say that the X bar chart tracks the average of samples over time. For example, measuring the weight of 10 boxes of a product every hour. And for the R chart, we can say that tracks the range or difference between the maximum and minimum values within each sample. For example, for the same 10 boxes, the R chart will track the variability in weight. And we had the real examples in previous session about these charts. Why use both charts? The X bar chart identifies shifts in the process mean. The R chart highlights changes in variability or dispersion. So, attribute charts are used when data is qualitative, like the fact, counts, or proportion. That is the basic of our explanation and information that in this session we are gonna practice together. We are gonna talk about this together. So, P chart or proportion chart tracks the proportion of defective items in a sample. For example, out of 100 shirts, if 5 are defective, the proportion is 5%. C chart or count chart monitors the number of defects per unit. For example, counting scratches on a car's paint job. Or U chart is the last one that we are going to talk about this. It tracks defects per unit but adjusts for varying sample sizes. So, guys, for the numerical data like length and weight, you should use the X bar and R charts. For the measuring the quality, if you have some numerical data, that means that like length, weight, you should use the X bar and R charts. If you have the qualitative data, for example, it's about the good, the bad, it's you want to speak about the pass, fail, about a production, you should use P, C, and U charts. For numerical data, for example, length, weight, and temperature, and etc., for measurable and comparable data, use X bar and R charts. These charts help monitor the mean and variability of the data. Okay, we have some example that you can touch more about this kind of charts. Example for the numerical data. Numerical data, you should say, please say to me, when you have a numerical data, which one of the chart you should use for the measuring your quality? For example, quality the product or business, everything. Yes, X bar and R chart. So the example for the numerical data is, for example, imagine that paint thickness of car. Uh, a, a car manufacturing plant wants to ensure the paint thickness on car bodies is within the standard range. They use X bar and R chart. And the next example is weight of food packages. A snack company monitors the weight of chips packages to ensure they meet the labeled weight. It should be used the X bar and R chart. Temperature in production is the numerical data. A chemical company tracks the temperature of a reactions tank sorry, during a process to maintain consistency. This is the numerical data, so we should use the X bar and R chart. The last one, for example, length of metal parts. A mechanical parts factory ensures the length of produced parts remains within specified limits. So they should use the X bar or R chart for the measuring of this quality. So on the other hand, that it is the main topic that for this session we are focused on is about the quality data, qualitative data. Means that the good, bad, defective, and non-defective. For classified data that cannot be measured, use P, C, and U charts. These charts track the percentage or count of defects. So, some example about the qualitative data. For example, defective products percentage. In a home application factory, the percentage of defective refrigerators in a batch is calculated using a P chart because you want to measure the some qualitative of the quality of this product. Qualitative data, not numeric data. So the next one is the scratches on the glass. A glass manufacturing plant counts the number of scratches on glass surfaces and uses a C chart to monitor defects because it's not countable. So they should use some qualitative data for this. And the third one, for example, the packaging quality. Imagine that a food packaging company monitors the percentage of damaged packages using a P chart. And printing error. In a printing company, the number of printing defects, for example, extra ink or alignment issues per sample is recorded with a C chart because it's not numerical. So, guys, the advantages and applications of charts, means that the X bar and R chart ideal for process requiring high precision and numerical control. But if you want to have a useful for if you want to have some monitoring qualitative process where detailed numerical data might not be available, you should use the P, C, and U chart, and it is very useful for monitoring actually. So guys, the last one, we're gonna talk about the role of process capability. What's this? CP, the process capability ratio, is a measure used to evaluate how well a process can meet the specified limits of a product or service. It compares the width or width of the specifications range, means the difference between the upper specification limit USL and the lower specification limit LSL to the process variation that measured by, for example, 6 times the standard deviation. As you can see in this formula. Sorry, I should clear While a CP, the result from this formula, is lower than 1, suggests that the process is not meeting the specifications consistently and needs improvement. Essentially, CP means that the process of capability helps assess whether a process is precise and reliable in delivering outputs within the desired limits. Process capability measures how well a process meets specifications. As I told you, the formula is USL minus LSL divided to 6 standard deviation. Target bursting range is 300 PCI, and USL, this is the data that actually I want to say you about this. This is the constant data from one example. And we have the USL is 316 PSI and LSL is 240. So the capability, process capability is 360 minus 240 divided to 6 is the constant, multiple to a standard deviation. In this example, the standard deviation, for example, is 32. Sometimes you should calculate the standard deviation, but sometimes you have this standard deviation according by some data, and today it's not important that you uh, calculate this standard deviation, because this is ready for using. Interpretation for the process capability. When process capability is lower than 1, as I told you, indicates the process needs improvement. So it is very important that after calculating this formula, if the process capability is lower than 1, you should recheck your process. You should improve your process, and you should reschedule for your process for the quality. So guys, please let me, I'm gonna check is it finish or not. Yes, yes, this is the rule of this and this. So it's okay. But guys, before finishing this session, one more time, the key takeaways should know that the control chart helps detect process variability and maintain stability. X bar and R charts are ideal for numerical data, while P, C, and U chart work for attribute data. And on the other hand, the process capability analysis ensure the process aligned with customer specification. This is very important, this data for the process capability. You can use from this formula for the process capability and analyzing the and then ensuring for the process for your process that this is aligned with your customer specification or not. So guys, thank you so much for staying with me as we explored control charts and process capability analysis. These tools are invaluable for improving quality and ensuring customer satisfaction. In this session is the final session for the quality management. And actually I'm gonna prepare some notes for the other videos about the quality of the management. You can use these files, and it is very useful for you. It's continuously from these videos, and you can use these videos, and after that these videos you can use this file and notes, and this is very helpful for you. So remember, quality is not just about meeting a standard, it's about exceeding expectation. Thank you so much. Have a good time, and I will see you for the next time, but with new topic. Thank you and goodbye.